Hey there, students. In this clip, we're going to be going over two examples on how to solve exponential equations. So let's go ahead and take a look at question number one. The task is to solve um, 5e to the x plus 2 equals 8e to the 8x for x. Okay? All right, so let's copy this down again. We want to solve this exponential equation for x. It's an exponential equation because it involves e. So to do this, what we have to do is we want to isolate, place all the terms with the um, exponential expression on one side and then put the constants on the other side. And then we can focus on eliminating e and then solving the resulting equation. Okay, so if you notice this uh, term right here is composed of constant and then an exponential expression. So we're going to think of how to separate it, and this is a constant, but this exponential expression has a variable and a number, okay? So what I want to do is I like to simplify this into a term that has e to the x times some number a, okay? And then that will enable me to collect all the exponential expressions on the left side and then put all the constants on the other side. So let's focus on dismembering this exponential term right here. So I'm going to write this as 5 times e to the x times e to the second. Okay, that equals 8e to the 8x. Now, how is this possible? Remember the product property of exponents. If you're multiplying two exponents with the same base, a to the x times a to the y, what do you normally do with the powers? You add them, right? A to the x plus y. So that's exactly what we're doing here. But what we're doing is we're doing the reverse. Okay, since we have the sum, we can express the sum as a product of two exponential expressions with the same base. All right, so that's what we did here. If this equals that, then that equals this also. It goes both directions. All right, so now I want to collect all the e to the x on one side and all the terms with all the constants on the other side. Now, this is an exponential term. This is an exponential term. This is a constant. 5 is a constant. E squared is a constant. And 8 is a constant. Okay? So let's see. I like to place my exponential expression on the right because this has a bigger power than this one. And then all my constants on the left. So the question is how we're going to accomplish that. Well, just by simply dividing. What I'll do is I'll divide the left side by 5 b squared. So if I divide both sides by 5, wait, wrong approach. That moves it to the right. I need the 8 over there, so it's better to divide by 8. So let's divide both sides by 8. So if I divide both sides by 8, the 8 is canceled out, divides out on the right side, and it shifts to the left side, okay? And I also need the e to the x on the right side. So what do I divide by? You divide by e to the x also. So if I divide both sides by e to the x, by division, this cancels out, all right? So let's see what happens. On the left side, e to the x divided out to 1. And then on the right side, the 8 divides out. So we are left with 5 e squared over 8 equals e to the 8x over e to the x. Okay? Now let's use the quotient property of exponents to simplify this exponential expression. Remember the rules for that. If you have the quotient of two exponents with the same base, all you simply do is subtract the powers. You subtract the power of the denominator from that of the numerator. So we're going to apply that here. So use the reflexive property of equality. Let me switch it around. We have e to the 8x minus the power of the base, which is x. E to the x minus x equals 5e squared over 8. Now this is a number, so we can leave it alone. We don't have to do anything to it. Okay, so let's leave that alone. All right, simplify that. This simplifies into e to the 7x equals 5e squared over 8. Now to get To power down this exponent, what we're going to do is we're going to take the natural logarithm of both sides of the equation. All right, so we're going to take the natural logarithm of e to the 7x, and then on the right side, we'll do the same thing to preserve equality. We'll take the natural logarithm of 5e squared over 8. Okay, now on the left side, the natural logarithm and the e, they cancel out. So we're left with, let me see, we're left with 7x equals the natural logarithm of 5e squared over 8. To finish this up, we just divide by 7 or multiply both sides by the reciprocal of 7. So let's multiply it by 1 over 7. The same thing as dividing, but I don't want to make a mess on the right side, so that's a better approach, okay? So this 7 and that 7 divides out. Well, and then we're going to end up with the answer, x equals 1 over 7 times the natural logarithm of 5e squared over 8. Okay, so that's your answer for question number 1. All right, let's take a look at question number 2. Um, so for question number 2, the task is to find the coordinates of the point of intersection of y equals e to the 4x and y equals e to the 2x. Okay, so how do we solve this problem? These are two exponential functions that intersect at a point. So the question is asking us to find what the coordinate of the point of intersection is. So in order to solve this, what we'll do is simply set both sides equal to zero to each other. So e to the 4x, we'll set it equal to e to the 2x. Now, if we solve this equation, it will tell us the x-coordinate of the point of intersection. And then what we'll do after that is plug it back into the original function to determine the y-coordinate of the point of intersection. All right, so let's go ahead and solve this. So actually, let's make a change here. There's a 3. Okay, I can leave it like this. Okay. All right, so let's go ahead and solve this. So in order to solve this, we want all the terms with the exponential expression on one side. So any constants on the other side. So we have two exponential expressions. So I need this e to the 2x on the left side, but I don't want to create two terms on the left side. So what I'll do is I will divide both sides by e to the 2x, and divide that by um, e to the 2x. So on the right side of the equation, it divides out to 1. So the side is 1. And using the quotient property of exponents, since your bases are the same, this can be written as e to the 4x minus 2x. Okay? Now if we simplify that, we're going to have e to the 2x equals 1. To finish this up, we just simply take the natural logarithm of both sides. So the natural logarithm of e to the 2x equals the natural logarithm of 1. All right, so the natural logarithm of e to the 2x, those divide out. These two divide out, so you have 2x, and remember natural logarithm of 1 is 0. Or you can think of 1 as, we can write 1 as ln of e to the 0, right? Anything to the 0th power is 1. So I can write this as ln of e to the 0, and you can see that that is the same thing as, you can power down to 0. 0 times ln of e, which is just 0. Okay, divide both sides by 2. We have x equals 0. Now that's the x-coordinate of the point of intersection. Now to find the y-coordinate, we're just going to evaluate y at 0 for whichever function. It doesn't really matter. Okay, so let's do e to the 4x. So it's going to be e to the 4 times 0, which is going to be e to the 0, which equals 1. So y equals 1. So in conclusion, the coordinate of the point of intersection of y equals e to the 4x and y equals e to the 2x is 0, comma 1. Okay, so that's the coordinate of the point of intersection of our two exponential functions. All right, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel, and if you like this video, you can click like. Please post a comment to let me know what you think about this clip. More clips come from at theserve.com. Thanks again for watching, and have a wonderful day.